Hello all. Again, today I came back with one more challenging puzzle targeted to grade 8 to grade 12 students. And in this we have a triangle which is isosceles triangle. So for that isosceles triangle, its two sides AB and AC are of same length. The area of this triangle is 8 units. PQRS is a square that is embedded in this triangle here. P is on side AB, Q is on side AC, SR is on side BC. What is the maximum possible length of this square? So given an isosceles triangle of a particular area, what is the maximum side of a square that we can fit into it as shown in the figure? That's the challenge we have to solve today. To solve this, we need to understand some basic concepts in geometry. And after that, since it is an optimization problem, fitting a maximum possible length of the square in a triangle of a given size, we need to use some algebraic properties to solve it. Hope you are ready to solve this question along with me. Please try to solve this on your own and come back and check the solution. Thank you. Hope you have solved this question and have answer ready, and also that you are ready to cross-check your solution with me. So what do we have here? We have an isosceles triangle ABC. We know that length AB equal to length AC, and also know that PQRS is a square. From that, let us assume the length of the square as x. So PQ equal to QS equal to RS equal to PR equal to x. So we can write that as follows. And let us assume the base of this isosceles triangle BC. So the length of BC, let us assume that equal to B. We have that too. Next, let the height of isosceles triangle ABC, AM equal to H. Let us assume that AM equal to H. Since ABC is an isosceles triangle, the perpendicular line from A to BC, which is the height, will bisect BC, meaning BM equal to MC. We'll come back to that later. So for now, we assume that AM equal to H. So what do we get from there? So the area of the triangle ABC, we know the area of the triangle method. It is half times base times height. So base we assume that it is B, height we assume that is H. So half times base times H equal to 8. So base times height equal to 16. All good till now. So we started with 16 units, which is the 8 units, which is the area of the isosceles triangle, and we related that to base of the triangle and the height of the triangle. Next, PQRS is a square, meaning the side PQ is parallel to RS and RS is on BC. So the line PQ is parallel to line BC. From this we can derive that triangle ABC is similar to triangle APQ, meaning the ratio of their sides will be the same. From that, we also know that since AM is intersecting BC and ABC is similar to APQ, AM, which is the height of triangle ABC, will also be the height of triangle APQ. So AM intersects PQ at N. So PN equal to NQ will be equal to x by 2, because x is the length of the square, Pn equal to nq equal to x by 2. Okay, did you follow till now? Next, we'll go to the other. Since AM also bisects BC, we can say that BM equal to MC equal to B by 2. All good till now? Next. Since AM bisects PQ and BC, we can conclude that triangle ANP and triangle AMB are similar triangles. From that, what we can write is AM by BM will be equal to AN by PN. So what is AM? We know that AM is H. What is BM? BM is half of BC, which is equal to B by 2. What is AN? So we know that this entire length AM is H, and PR, which is the side of the square, is X. So AN will be H minus X. So AN is H minus X. What is PN? We derived that. We derived that PN is X by 2. So we can write as H by B by 2 equals H minus X by X by 2, which can be rewritten as H times X equal to H minus X times B. We can expand this similarly. From this, we can write it as X, which is the length of the square we are trying to solve, equals to height times base of this triangle divided by height plus base of this triangle. Okay, so till now we established the relationship between the dimensions of the square and the dimensions of the triangle. So we'll go to the next phase. In this phase, we will use algebra to solve this problem. Now we'll come to the algebra side of this problem. In the previous page, we derived that X, the side of the square is H times B by H plus B. As I explained before, this becomes an algebra problem right now. Now we have, since H and B are two real numbers, square root of H minus square root of B whole square is always greater than or equal to 0, because square of any number is always greater than or equal to 0. From this, we can write it as H plus B minus 2 square root of HB is always greater than or equal to 0. We can write that H plus B is greater than or equal to 2 times square root of H times B. So how, if we just take this H plus B onto this side and this 2 to the other side, we can say that half is always greater than square root of H times B by H plus B. So the maximum value of square root of H times B by H plus B is half. So the maximum value this expression square root of H times B by H plus B can take is half. We already know that X equal to H times B by H plus B. So maximum of X will be maximum of H times B by H plus B. If we rewrite this, the top one H times B, we can write it as square root of H times B times square root of H times B, right? So that will become, since we know that square root of H times B by H plus B, the maximum value of that is 1 by 2. So the maximum value of X is square root of H times B times 1 by 2. And from the area we solved, because the area of this triangle is 8, we derived in the previous page that H times B is 16. So square root of H times B is square root of 16. Square root of 16 is 4. So 4 times half. So the maximum length of this square can be 2. Hope you enjoyed my solution. If you like my solution and my content, please subscribe to my channel. Thank you.